Hey all, in this video we're going to take a fairly quick look at what has been just recently announced as general availability in Elastic, which is this ESQL, Elasticsearch Query Language. It's just recently come out. Of course, it's been in technical preview for a while, so many of you might have already looked at some of this or heard about it. But only in the last few days did it come out as part of actual general availability, which hopefully means that at this point there won't be any huge significant changes to how things work. And so hopefully this video won't be obsolete in a week or two, right? Hopefully it is actually useful for a little while people take a look at what exactly is different and what new things can you do using the new query language. So to do that, what I've done is I'm just running some Docker containers here for Elastic and Kibana. And what I have right now is I've manually uploaded some data to an index that I've just called sample data because I'm creative with names like that. And so what you will see is that typically where you would select your index, you now have a new option, which is the language ESQL. Because within the query search itself, using that language, that is where you specify the index you are pulling data from. So in this case, from sample data. And of course here, what we see is there's also a limit 10. So something to just be aware of is much like old Kibana, there's always some sort of limit on how many events you'll actually get back in your preview page and how many events you should actually get back with full data. In this case, limit, as you might expect, limits it to only 10. If you get rid of that, the default limit is something like 1,000. So you'll typically get like 1,000 results back and you'll get this warning here that tells you that. No limit defined, adding default limit of 1,000 in this case. And you can see I get 1,000 results down here. So that's just something to be aware of. There are still some limitations here that exist just to try to make things a little bit more efficient, because it's more than likely that you're not trying to look at 1,000 events at a time, right? So we can kind of manage things and expectations that way. But like I said, I uploaded some sample data to this. It's some old sample data from back in September of 2023. So it's data that was created quite some time ago. But within this data, there's one specific example that I think is a really great way to showcase some of the changes that have been put into ESQL to really kind of revolutionize how we can do searches in here. Now, I should say it's not like I'm getting paid by Elastic or anything like that, right? But like this was definitely a much needed update to the system. I mean, the old KQL for Kibana, it wasn't a bad language, but it was so limited in some cases when you were trying to actually do some really significant analysis on like even slightly complex data. Okay, so this was definitely needed, and that's why I'm so excited to kind of play with it now and see some of the differences and see some of the added functionality. So for our test case, what we're going to start with here is I'm going to not worry about this right now, and I'm going to start with a where statement. So no surprise here, where statement is just another filter. You're looking for specific things in specific fields. So in this case, I care about log type, right? Because what I care about and where my example is in process logs that have these command line fields that are in them. So I'm going to say where log type like, and in quotations here, I'm going to say like process. So something to be aware of is that much like other implementations of the like keyword here, I can also use wildcards. And in some cases, I'm going to have to use wildcards to match on what I want. But regardless, we're getting process logs if I just look for process. Now, of course, things you have to pay attention to. If I uppercase that, I will get nothing. So it is case sensitive, so you have to be aware that that's case sensitive. But in this case, I'm just going to go for process. I know that's an exact match for the log type I care about, so I'm not going to worry too much about the other details right now. So once again, to log type process, I now care about command line fields. And in this case, I actually do need to care about some asterisks here from some wildcards here, and I need to pay attention to case. Because in this case, I am very specifically looking for an example I've already kind of identified, just for the sake of making this video a little bit quicker here. But I'm looking for bypass. And this is spelled incorrectly intentionally, because these are some logs from a compromised host. There was malware on it, and so we pulled this log off, and now we're going to use it. And this was one thing that kind of caught initial attention while looking through things, while doing queries, was somebody was using abbreviated and kind of mangled keywords and parameters for PowerShell executions. So if I do that, and I know it's going to be an uppercase B, I know this is exactly how it's spelled, and then I kind of filter down to just the command line here, we can start seeing some interesting events already. because we can see that there are events with like watches in them, which is certainly not standard behavior for PowerShell. So these are going to be things, these types of events are going to be what I'm looking at specifically. Now, why this is a really good test case is because luckily in this case, eventually the tool that was used to generate logs on this particular host eventually caught the unobfuscated version of this command. So we can really test this new language and make sure it's giving us the things we expect it to give us, okay? And of course, with the expectation that we might not actually see this on a host if it's been compromised, something might have happened. And so it's good to see that we can get from the original ourselves to what the final payload looks like, to what the final command looks like, without having to jump out of Kibana to go to things like CyberChef. You see I have a tab for CyberChef open. We're going to talk about that a little bit later. But for now, I really kind of care about these watch things, right? And so while this is a little bit contrived, again, just for the sake of having a good example, I'm going to do something a little crazy, and I'm just going to look for these watches. And hopefully, these watches only appear in these specific command lines. Hopefully, I'm not going to have any, contaminated data here if I just look for these specific things. And as we can see, we can kind of generally identify that, like, yeah, it looks like these are all going to be relatively the same thing that's going on, okay? So what we're going to do now is we're going to actually jump into the process of manipulating all of this data to try to get to an unobfuscated command. And we're going to do as much of it as possible using just the query language without jumping out of Kibana. So that's going to be hopefully what we achieve by doing this. So to begin with, we just matched on all of these watches. So perhaps the first thing we want to do is looking at this field here, looking at what's happening. We see what probably looks like a base 64 string. Again, if it wasn't for the watches, this would probably look exactly like a base 64 string. If we look at some of the commands that are being referenced here, and if I zoom perhaps a little bit more, I have to continuously try to make this readable, I suppose. We can see down here, the second command listed starts talking about from base 64 string after doing a replace, where it replaces these watches with a U. So let's do that. Let's see if we can do that using Elastic. And by the way, because it is kind of like the new piped language, you can in fact put this onto multiple lines. It doesn't need to be one line. But to begin with, how do we do this? Well, we're going to have to do some data manipulation here, but I don't want to get rid of this field. I don't want to mess up this field by itself. I want to leave the original data intact. So what I'm going to do is I'm going to make a new field. And I can do that using the eval statement. Now, this is similar to some other languages that are out there and similar data products that are out there. But we're going to say eval, and then we have to give it the name of a field. Now, this isn't the best name, but I'm just going to say normalize for the sake of having an easily referenced field, okay? And what I want to do is I want to do a replace operation here. And so what I need to do is I need to give it the field we are targeting, what we want to replace. So in this case, we can just stick with these watches, okay? So we want to actually get rid of these, and so I'll just copy those over, and then we want to replace it with a U, because remember, when we looked over here, it was a U that we're replacing all of these watches with. So when we do that, we should expect to get a field normalized. And in fact, we do. So here we can see that this field actually does exist as we expect. That already is a significant improvement on the functionality of working in Kibana. Now, of course, previously you could use things like painless, you could make some like runtime field, and there are ways to do that. It was wildly inefficient and it really hurt your processing. But like you could sort of do it if you had enough technical expertise in how that works. But like now it's just a very simple, efficient command, just eval, right? Like it's so much easier to do this. And now I have this other field here. Now, what you can also do, and this might help out for, looking at some forms of efficiency. I don't have exact benchmarks or anything like that, but I'm only going to be working with some of these fields. I really don't need all these other fields that are in this event. So to kind of keep that down to a minimum, I'm just going to specify which fields I actually care about having. And so when I do that, now the event is down to just these two fields because that's all I really care about. And I can kind of continue working my way through this problem. So the next problem that we have to worry about here is we now have this base 64 string. Well, that's cool, but I can't read base 64. I don't know immediately what this decodes to. So we have to figure out a way to actually get this base 64 string out and how we might be able to decode it. And again, to kind of show some of the capabilities here, I'm going to do this in two steps. So the first step is, yet again, I need to make a new field. And so what I can actually do though is, instead of using eval, this time I can use the grok command. And just as, full disclosure here, I am not a regular user of grok, okay? So there might be a better way to do this once we get to this pattern matching. But regardless, this is just to show some of the capabilities, right? So we say grok, we want to take something out of the normalized field. And so what kind of pattern are we going to try to match here? Well, in this case, we get lucky. Because as it turns out, this is the first example where something is actually in single quotes in this particular command. And so I could really just do something as simple as, okay, let's put some single quotes there. And then the actual grok pattern we care about is anything that's just not space. And we want to take that data and put it into a field called encoded. So again, we were looking for something in the first instance of something between single quotes. And what we care about is we're going to match on the pattern not space. And everything we match on, we're going to dump into a field called encoded. And so when we do that, now we should have a field called encoded. And when we look at the event again, here it is. And it worked like a charm, right? Like we have all that entire base64 string now in its own separate field. And that's for all of these events, right? Like all 36 of these events are going to have this field if the pattern is consistent, right? If they are consistently in the normalized field, the first instance of something between these single quotes. So that can obviously vary very widely, but that's just, the quick way to do it here. Again, we're being somewhat contrived, but I mean, this is a real event, and this is how the real analysis might unfold. So now, again, that was the first step. I still can't read this, right? Like, how has that helped us? Well, here's where we get into another very helpful command that we can work with, but it does have a little bit of a weird bug, maybe. I'll call it a bug for now, but I'll explain. So what we can do is we're going to make a new field using eval. We're going to call it decoded. And we're going to use this function called from base64. And when you do that, you have to give it the field you care about. So I care about the encoded field. So here's the weird bug thing that I'm not totally sure why this is happening. If I look at this error, it's going to tell me that this is an unknown function. Of course, I know this function exists because it's in the documentation. I've played with it a little bit already. I know it exists. I know it works. And in fact, despite this error, if I run this and then I look in my events for the decoded field, you will see that everything worked. So I'm not totally sure why the from base64 is causing this error, because it's clearly a function that's working, but that might just be a little hiccup thing. I don't have a better explanation for why that's happening right now, but just be aware that sometimes some things do still perhaps need a little bit of work in terms of the syntax parser and the linter and stuff like that. Maybe there's something else that's going on that in the background that is causing that particular problem. But regardless, we now have a decoded base64 string as a searchable field that we can now work with and manipulate and do whatever we need with. So just to kind of like put this into perspective, in old Kibana, once we found this event, it was very likely that you immediately had to jump out of Kibana to some other tool to actually deal with this and work with it at all. But now we've gone from this somewhat obfuscated, weird base64 encoded command all the way through down to actually being able to have a field that has the decoded data, the deobfuscated data, and we did all of that in Kibana. We didn't have to leave it all. It's just super nice because now I can also use this for all of these events and compare the decoded commands to see if there's any differences in them. I don't have to jump in and out comparing base64 blobs and decoding base64 blobs in Chef and then jumping back to Kibana and looking for the differences. We can do all of that now here in Kibana. Now that I've given that praise, there is a bit of an issue that we have to identify here. And unfortunately, what that is we have this weird, garbly-gook string of weirdness, right? And if we look back at the original command, our next step should have been to do a replace function where we replaced this string here with this path, which is the destination of the payload that is being kind of created here. But unfortunately, this is not what we got when we decoded the base64 string. Instead, and we see we got those 3 H's. The 3 H's are correct, but we got this other kind of mess here. And unfortunately, you can't do anything with that mess. So if I try to actually go down, for example, and do an eval final, let's say final command kind of thing here, and we say replace, and we want to replace decoded, and we want to replace that gook with, let's just say test. Unfortunately, if I do this, and I then open up an event and look down for final, what you're going to see is we still just, it's certainly not test, right? Like we weren't able to actually match, which is somewhat expected. Like given just how the encodings work, we would not expect to be able to match on the unknown characters depending upon how they're being parsed. And so that's the key here. What I think is likely happening is that if we jump into CyberChef to kind of demonstrate this here, if we try to go through the process of doing it here, and then I'm going to remove the nulls, what you will notice is if we do it in CyberChef this way, we're also getting gobbledygook. But the difference here is that if I had this on the default should be raw bytes. You'll notice it does give me what I expect. And it also gives me what I expect if I go to UTF-7. But unfortunately, if my encoding is UTF-8, we start kind of running into problems here and there. And so my guess is that the from base 64 decoding that is happening, it is probably it's probably not able to figure out the best encoding to use. It's probably set to UTF-8 or something else. And so unfortunately, when that gets parsed in, that becomes a problem. And the reason I think it's specifically from the from base 64 function is because in our original event, we're obviously able to see this without any problems, right? We're able to represent that exactly as we expected. So I do think that this is perhaps an encoding issue. And looking through the documentation, I don't think there's anything we can do about that. I don't think that function allows you to specify encodings of any kind. So not a huge deal, because at this point, we can just look and make the comparison and say, okay, all we would have really done here is replaced this with something that's not obfuscated, right? Something we can already read anyways. So that wouldn't have been too big of a deal, but it would have been nice if we could have gotten all the way to the finish line just using Kibana by itself, right? But we are so close, and it's such an improvement over the previous iteration that it's hard to really complain. So anyways, this decoded field now contains the full decoded version of that base 64. And as we've worked our way through the command, we saw that the rest of this command was mostly just replacing and cleaning up the obfuscation itself before we finally just kind of execute the final command itself, which is effectively what we have in our decoded field, again, minus the full path of where rotocopy is actually making the transfer to, the copy to. And the only other thing here, there is a reversed string. Theoretically, we could probably use a regex to pull that out and reverse it. I don't think there's any sort of default built-in like reverse function that I saw, at least in the documentation. It certainly could be there. Again, I've only looked at this for a very brief period of time so far. I just wanted to kind of show some examples here because it was pretty cool to get this far with this data. But that's kind of a minor thing. Again, it's not like it's actually obfuscated. We can generally understand what's happening here, and basically there's two different calls to CDN Discord app type domains here where they're trying to get some malicious stuff from attachments that are being held, which is not something new. And again, this data is from forever ago. It's been kind of changed and cleaned up quite a bit and like, again, manipulated a little bit so that we could use it as an example. But it's basically an old technique that still sometimes pops up here and there. So just something to be aware of. But anyways, that basically concludes the explanation and the walkthrough of some of the things you can do using this new language. So we talked about, setting the index, using where statements, and understand there is some, there's some case sensitivity involved here, and you are likely to use the wildcards to actually get full matches of what you want. Now, to be clear, there are other options for using the where command. You don't have to use like, there are other options, but for the sake of time, we only talked about like in this instance. We talked about using eval to create your own fields, potentially using things like replace or from base 64. We talked about keeping certain fields to really minimize the data set to what you really only need. We talked a little bit about grok and how you can use grok to make a new field based upon, some extractions and some pattern matching that you might need to do. So hopefully all of that was helpful to you. Hopefully it makes sense. Hopefully I gave you some ideas for things that maybe you want to test out. And hey, maybe you, for the first time, saw an interesting malicious PowerShell command. Regardless, hopefully after all of that, you're able to take something away from this video and you can understand why this is definitely a significant upgrade for Kibana and the Elastic team. So job well done, honestly, on getting this out. This is much, much better than some of the other previous language uses that were available. That being said, that pretty much covers it for this video, so thanks for watching.